Dear students, my name is Andrei Lee. I'm going to explain you a trick and give you a short walkthrough on Udacity Project 5 phase generation exercise. This is a GAN. We are given sample faces, and from these sample faces we have to generate new faces. So GANs generating something new, and these new faces are presented here. As you can see, they're very realistic. They look like real people, so the quality is okay. So let me give you the main trick of this of the GAN. So young Goodfellow mentioned that we have to watch to find a kind of a balance between discriminator loss and generator loss, and I will explain you what particularly you are looking for and what particularly he meant by saying that. So let me show you. This is a generated discriminator loss. So what you should do? Let me show you losses. This is a D loss is a discriminator loss and G loss is generator loss. So when you start training, discriminator loss is high and generator loss is low. So this is where the whole process where it's a process of creation the main picture, the creation the new pictures. Okay, and when they cross discriminator losses for example 1 and generator losses 1, it's where it's find this balance, and after that discriminator loss is low and generator loss is high. So this is where training is usually stopped. So you train pictures, the rest is the fine tuning. So you can go and consider more epochs, but these are fine. So how to control that? So you can see that in this picture we have a discriminator generator loss crossing, and then this is where the whole magic happens. So how to control this losses graph? I found a way. It's a unique material, but you know, one thing when you explain it, and the second thing is when you apply this real knowledge. So we are going to show you the practice what the young Goodfellow mean in his explanation. So how to control that? To control that, we control the batch size, sample size. So in the exercise, you cannot change this value. It's 16, and batch size right over here. So batch size 20. So 16 is fixed. And at first, when I started doing this project, I thought batch size it's important, but it's not that important. But what you're actually controlling is you're controlling difference between generator and discriminator. Generator might generate more images, and that's why you can work on a decreasing value of generator if generator generates more images. Or you can make a discriminator generate give more output. So this is how it's worked, and this is difference extremely important. Okay, controlling this value, you control the this loss feature. So it's a very complex trick, but if you understand it, you will be master of guns. At least I hope. So you have to be careful and you have to try. So let me give you a short walkthrough of how it is all looking. So briefly explain what we have to do in this project. First, we unzip the file where our pictures are. We import libraries. Let me do it right now. So I execute the cell. It's correctly. Don't look at the message unzip because the file is already unzipped and everything is fine. So we import we reference directory, And then we import necessary libraries, matplotlib, pickle to save the file, to save the data in file, problem unit test. So everything is here, and let's go further. Then we import torch vision, create data loader, define hyperparameters. Batch size is extremely important, as I already said you. So everything is fine. That's where we are showing sample images. So this is the real images. These are not fakes. So this is real. We scale from -1 to 1. As you can see, it's scaled correctly. And then we import additional libraries from Torch. Define discriminator, define generator, initialize weights. So this is a very interesting procedure. So it's kind of give you more understanding of internals of PyTorch. So, and everything's fine. So this is where they define norm weights. So for example, if you want to see the model, uh, you can type your model, like when you instantiate your class, you just type your class and you see the whole model, but we will see that later. Build network, define our network, and here we can see our model definition. So everything is clear here. Then we train on GPU if you have GPU. I have GPU available, so this is a perfect thing. Then we decide on real loss and fake loss. What's the real loss? What's the fake loss? Real loss it's when we feed in real pictures to the neural network, and it gives us a real loss. Like what? It's kind of a good, right pictures. Okay, the real pictures. And as you can see, we define labels as torch once of batch size, and it give us once, and this is our labels. We multiply by 0.9 to make the model train more if there is a smooth parameter. It's set for false. If it's set for false, we are feeding real pictures, and when it's set to true, we are training our fake generated images from the noise, and we multiply it if smooth through fake images. We multiply it by 0.9 to make the model train more. So it's kind of a not realizing that this is the ideal picture. There is some room for improvement by saying this multiply by 0.9. Then we define fake loss. This is our fake images. You see that it stores zeros as the labels, all zeros. It's not real. And then we define optimizers. So here the learning rate is 0.005. This is extremely important parameter. This is a very good article on Medium that explains why it's this number. It's a local minima according to the article, and this number is a magic number. It's when the fast and most accurate training happens. We define bettis, momentum. So there is also trick here. Be careful. Don't define it as a list. So manual says that it should be tuple. So make it tuple. Otherwise you would be stuck. So I tried using list, and it's not generating. It's not training correctly. So do according to the manual. Although some people do it, but there is a small. It's not a bug of PyTorch. It's like read the manual thing. You know, you have to read the manual and do it exactly as manual says. Otherwise, you will not train your guns and you will have problems. So be careful with this issue. So define it correctly and put the numbers correctly. I choose 0.3. It was recommended to me, and I think this is a good value. If you put here 0.5, for example, momentum. Momentum is a kind of a when method to avoid local minima. So it kind of runs faster and then go through the local minima and find global minima. So it's kind of your speed, if I can say so, when you're training your model. So be careful with this because you can spend hours, and when you give parameters as a list, and it will not train. So be careful. Read the manual. Rule number 1. Then we train our model. We define training function. So everything here is clear. And then we train the model. I will not start this. So it will train the model. So here we have an epoch, discriminator loss, generator loss, everything is clear. Then we have this nice picture provided by Udacity. Provided a nice snippet of code provided by Udacity to make a nice picture. Then we view samples, and voila, we have a nice pictures of people that have never ever existed before. And this is the power of GAN. So I hope you enjoyed this video. I can explain you this for hours. If you want, you can. I'm ready available for you to explain more. So stay tuned and do more exercises. Okay, happy coding.